is credited with shaping modern education system of India. His focus was on free primary education to all. Azad was awarded Bharat Ratna in 1992 for his contribution towards the field of education. It was under his tenure that the first IIT, IISc, School of Planning and Agricultural and the University Grant Commissions were established. So another stalwart, the Children's Day is celebrated across India to increase awareness of the rights, care and education for children. It is celebrated on 14th November every year as tribute to India's first Prime Minister, Jawaharlal Nehru, fondly known as Nehru Mama among children. He advocated for children to have fulfilled education. So it is our duty to remember these stalwarts and their enormous contributions for the development of our country. So now coming to the today lecture, emerging trend in automation technologies will be of more beneficial to every one of us. On behalf of Institution of Engineers and other professional bodies, I extend a warm welcome to Mr. Santhosh, and thank you very much for kindly consented to deliver this talk.
Thank you, sir.
Once again, I extend a warm welcome to every one of you. Thank you.
Yes, sir. Thank you, sir. Thank you, Dr. Kumaresan. I welcome all our members, committee members, our all the professional bodies members, and Sankaran also. The Sankaran's past chairman also is the line. Our state secretary is also in the line. Thank you for joining with us. Now it is my happy to introduce our today's speaker, Mr. Santhosh, to our participants. There is Santhosh is working in the Department of Sales and Didactics. He's working as a senior manager. He is working in Hydac India Private Limited since 2019. Responsible for setting up of CEO Center of Excellence at technical institutions, development of training systems, impart training on various fields of automation technologies. His previous work experiences are: he is working in Mr. Kirloskar Electric Company, Mysore, as a trainee from 1999 to 2000. He worked in Pneumatic Automation, Mysore, as application support engineer. Sorry, there is a disturbance in this thing. Pneumatic Automation, Mysore, as application support engineer from 2001 to 2002. He has also worked in Hydac Engineering Private Limited as quality engineer from 2002 to 2005. He has also worked in Chartered Semiconductors as semiconductor technician from 2005 to 2007, and he has also worked in the Vast Rextroth India Private Limited as a senior manager from 2007 to 2019. He is about his previous work experience, and the key highlights is about Boss Rextroth AG, certified trainer for continuous control hydraulics, pneumatics, tronics, digital hydraulics, mobile hydraulics, and industry 4. Key personnel for digital hydraulics and proportional hydraulics in India. His contact details are: his contact number is 9731322550, and his email. I welcome Dr. the Engineer Santhosh for today's program. Welcome, sir. Over to Engineer Santhosh, please, sir.
Thank you, sir. So good evening, everyone. First of all, I would like to thank Institution of Engineers, Tiruchirappalli, for providing this opportunity to address you all. So it is again a pleasure for me to present something on automation, which is I carry a lot of passion towards automation. So in this total experience of 20 years, I have worked in various fields of automation. So it's a very prestigious thing that I'll be sharing my experience to you all. So I request everybody, if you have any doubts or questions, I request you to please post it in the chat box, or at the end of the session, we can, I'll try to do my best to address all your queries. So with this, I'll just start my topic. But before I start my topic, I would like to give you a very, very brief introduction about the company which I'm working for. It's basically known as Hydac which is basically a German company. It's a multinational company. Its headquarters in Germany, and in India we are predominantly present. So as this particular company is a technology oriented company, again, the name itself represents our first product, which was an hydraulic accumulator. So the name of this company is also derived from our first product, which is hydraulic accumulator. And in fact, the logo shape of the logo also resemblance to a ISO certified graphical symbol of an accumulator itself. So this was our first product. So I'll not be taking much of time in the introduction of the company. So we have got around 30 manufacturing plants across the globe, and out of which we have got a lot of subsidiary companies. So it's a group of companies, it's not a single entity. So we have got n number of products, and to cater to the automation field itself, we have got different companies which is already there on the screen. Further, what do we do? Basically, what are our products? We are predominantly into hydraulics. We are almost close to 7-decade-old company. Earlier, we were merged into a bigger company known as Rexroth. But since Bosch took over Rexroth, we became an independent company, and we started developing technologies and started having a market share in that. So basically, we supply components related to hydraulics and lot of sensors which goes into automation, and again a lot of data acquisition system. And since the last decade is on to a new trend which we are going to discuss on, so we have got a lot of products towards something called as Industry 4.0 also. Apart from that, we build a lot of customized hydraulic systems or automation systems for industries. And last but not the least, we are also into fluid engineering and service, because our core product is hydraulics, and for hydraulics, fluid is the utmost important parameter. So we are dedicating a lot of things towards fluid maintenance, cleanliness and all. And to do that, we have got a dedicated global R&D center in Germany for it. None of the other companies are having a dedicated R&D center for fluid engineering, but we do have that. So you name any industry sector, whether it's a machine tool or whether it's earth moving equipments or bulk material handling, power generation, steel manufacturing, cement manufacturing, offshore, renewable energy, especially wind turbines, we are present in almost every one of the sector. So when I say we are present, we are providing solutions either to these people or they are using some of our components or services. So of late, though this company is in existence in India since 1995, we have been very much active in the industry part. However, when it came to training, especially training, we were not that much focused. So since 2019, since I have joined this particular company, we have started a separate department and a wing for training and services, which we predominantly call as Hydac Academy. So we are working towards educating a lot of our customers, and at the same time, we are also working with the future engineers, especially the young engineers. So we want to build this industrial knowledge right in their education time itself, and we are working a lot with a lot of universities and institutions. So when it comes to our manufacturing, we are having 5 manufacturing plants across India, out of which 2 of them are there in Maharashtra, that is in Mumbai. 2 of them are in Coimbatore, and 1 manufacturing plant we have got it in Bangalore also. So in Mahape plant, we predominantly manufacture auto transmission gearboxes for Mahindra and Mahindra. So it's completely provided by us. And rest all the plants are catering towards our automation services. So we have got 1 more upcoming plant in Coimbatore. So due to COVID, it's got delayed. But in November end, this plant is going to be fully functional now. So we are As I told you, we are in the education front also, supporting all technical institutions and universities. At the same time, one of our prime focus is also to train the industries, so which we are doing very actively since start of 2019. And in this process, to cater to training facilities, we have been working towards Industry 4.0, so which is our main topic today. So I'll be discussing more on these things. However, we have since 2019 we have built a lot of made in India products, especially for the education sector. So we have come up with a dedicated hydraulic training system. Then similarly, we have come up with pneumatic training systems. We have come up with programmable logic controllers and sensors a lot. So in sensors, we have got a very, very big variety, because sensors is one which is going to play a very, very key important role in the upcoming future technology. So we are catering into industrial sensors, process related sensors, advanced sensors like barcodes, RFIDs, and then again, we are also into something called as these things are upgradable to Industry 4.0. So we have developed all these things completely indigenized. Also, we provide robotic solutions and robotic training, for which we have got an exclusive tie-up with ABB Robots. And this particular product, which you can see on the screen right now, we call it as an IoT enabler or a IoT controller. So this product is completely conceptualized and completely 100% developed in India. So this can be used to convert any of your conventional missions into an IoT based mission. So this, we have also customized it further for education institutions, so that our young engineers can get trained on the latest concepts. And we have already have some success stories, which I can share it in the final session. So now coming to our main topic, emerging trends in automation technologies. So whenever we talk about automation, our first thing will come is industrial automation. So what is industrial automation? So industrial automation is the use of control systems. So basically, whenever we talk about control system, it's always a combination of certain amount of hardware and then which is governed or superseded or guided by some sort of softwares. So which can be such as basic as computers, which can do wonders at least. And at the same time, a complex mechatronic system such as robotics, which comprises of multiple technologies. So a bulkier robot will have hydraulics, pneumatics, electric drives and controls, everything, and superseded again by some high level algorithms for motion logic controlling, and which we basically refer as information technologies. And this particular process of combination of everything can be used to handle different process and machinery in any industries. Typically, there is always a misconception saying that any automation done is to replace human being and reduce the manpower. It can be seen in a other better prospective way, saying that whatever the automation or engineering we are doing, it is basically to assist human beings in order to make their life simpler. So this particular industrial automation terminology, we also refer it as, it is basically the second step beyond mechanization. So when we talk about various developments industries has done, so there we talk about different phases of where it has changed the way industry works. So automation is basically a second step beyond mechanization. So which are the technologies which are predominantly contributing to industrial automation? So few of the, just to name few, one is hydraulics. I work for a hydraulic company, so it was my duty to put hydraulics in place one. Otherwise, there is no specific order on it. Again, pneumatics. And then in a generalized way, electric drives and controls. But apart from this, we may also have something called as building technology, machine building technology, linear motion assemblies, assembly technology, so various other things. But primary when it comes to do the work. So for me, the prime important would be hydraulic, pneumatic, and electric drive and control. And when I say electric drive and control, it can be again uh, segregated into many other technologies which can be PLCs, which can be variable frequency drives, AC servo drives, computer numeric controls, DC drives, SCADA systems, DCS systems, and so on. So these all come under the umbrella of drives and controls. So these things didn't get evolved in a single day. So it has taken over a lot of years where each one of these particular technologies has got grown in a very, very drastic way and in a very scalable way. So just to give you an idea, I'm just taking hydraulics as a base. So the way I talk for hydraulics, the same thing it would be for pneumatics. And again, I'll a bit talk about electric drives and controls also. So when we talk about hydraulics alone as a technology, so it has evolved a lot over a period of time. So almost 2.5 centuries ago, the first law of hydraulics came, which was Pascal's law. So, and almost till a century old, till the late 18th century, there was no practical use of hydraulics. So if you see the technology wise, technology has grown over past 2 or 3 centuries now. So it all started after in the late 18th century when a person by name Joseph Bram came with a hydraulic leverage principle and a hydraulic jack further. So where they started using water as a energy carrier to work for hydraulics. So over a period of time, we changed from water to oil because of several disadvantages with water. So then eventually we came up with manual hydraulics where there were a lot of manually operated components to which I could control the flow, pressure, or direction and all of the fluid. And the next development was something called as electrically operated hydraulics. So we started using electrical solenoids in order to operate these particular components. And then over a period of time, we came up with something called as continuous control hydraulics, which is basically a superseded electronically based hydraulics. So instead of having a conventional solenoid which could do a discrete kind of operation like on and off, we came up with introduction of electronics which could do pulse width modulation, stepless control, and all those things. Then came something was servo hydraulics, which was very, very fast acting hydraulics. So just to give you an idea, so a basic or electrically operated hydraulics could work at an operational frequency of somewhere between 4 to 5 hertz or 4 to 5 cycles per second. So when continuous control hydraulics was introduced, so the best quality product which is catering to continuous control hydraulics can work at an operational frequency of 20 cycles per second. And then came servo, which took the whole application by storm, which could do this somewhere around 250 to 400 cycles per second. So the next development was something rather than working on improving the operational quality, we started increasing the functional capabilities or feasibilities. So then came digital hydraulics. So prior to digital hydraulics, whatever were there, that were all analog based. So we had to tune up some potentiometers and change some resistor value, change some dip switch setting in order to tune that particular controllers. So the moment digital hydraulics came, this introduced something called as softwares or information technology to govern all these things. So literally, I could tune up my whole amplifier card or my electronic card using a software and a computer. So I could just connect a cable between my hydraulic valve and my computer, and I could completely parameterize it. So which gave a lot of boost to industries. And then further on, we wanted much more flexibility, much more accessibility. Now we have come up with something called as connected hydraulics. So whether my valve is working in Germany or United States or Australia, I can sit in my office or my residence, and at my convenience of a smartphone, I can exactly see what is happening in real time there. So any support required, any tuning required, or any replacement required, it can be done from across the world. So this is what Industry 4.0 for us at the moment. So in the same way, hydraulics or pneumatics also has grown. And when it comes to electronic controllers like PLC, if I take an example, so programmable logic controllers. So way back, since its inception somewhere in the early 1980s, when microprocessors, microcontrollers came into existence, the same thing was built for industrial standards, which was called as programmable logic controllers. So these kind of controllers earlier, it could be programmed by a dedicated handheld readers earlier. So where every manufacturer of these kind of products had his own version of or his own methodology in which these particular things could be programmed. But over a period of time, when people started understanding this product, started using it, and it became as a generalized product, then came the IT into it. So where we could program this particular program, we're using a laptop and a software. And further, the methodology in which these particular things were programmed, or the languages in which I could program this, were also under some guidelines and standards. So every PLC in the world came under this particular umbrella, where if I learn a method of programming called as ladder diagram, I am capable of programming any PLC in the world. So, but at the same time, we had few more limitations, like if I buy say Siemens PLC, I could program this particular PLC only by using a Siemens software. However, with the present scenario now, we have got very high-end PLCs and intelligent PLCs, where irrespective of the software I have, irrespective of the programming languages I'm aware, so if I'm good at C, I can use C program to write a program to the PLC. So similarly, if I'm good with Java, I can use Java as a tool to program my PLC. So the barriers were opened up with the new technology, which we call it as open core engineering, or we generally call it as Industry 4.0. So however, you take any industrial clusters, so there is always a misconception now that with the latest automation technologies, one has to know software and software is going to rule the automation industry. In a way, it is true, but at the same time, the basic technologies which are there, which is your hydraulic, pneumatics, or electric drives and controls, these things will have its own place in the automation industry, and it cannot be replaced by software. These are physical and real products which are doing the work. These things can be only superseded by more and more of intelligence. However, these things will continue to prevail in the automation industry. However, the importance of software is continuously growing in the automation industry. So when we are in today's world, when we are talking about connected industries, connected machines, connected products, so the requirement of software, requirement of higher level of intelligence becomes utmost important. So there has been a drastic change in the recent years when it comes to consumer products also. So just to give you an idea, in 1997, there were around 6 million computers which were connected onto the internet. And in today's day, we are talking about 50 billion connected things. So we are not restricting the connectivity of internet only to computers. It has spread across every area now. So the televisions at home has become smart because it has got a connectivity to the internet. Your ACs have become smarter, your mobile phones have become smarter, and lot of things. So when it comes to industry also, it is the same thing now. So but these all these particular concepts were all initially come to the consumer markets. So where we predominantly started talking about a concept of IoT, Internet of Things. So we wanted all our things to get connected to the internet. I want my car to be connected to the internet, television, mobile phones, speakers, your household refrigerators, washing machine, ACs, everything became so feasible that it all got connected to internet for exchange of certain amount of information. So if I wanted to remotely turn on my car, I could do that using the platform of internet. So same thing came into industries also. And some of the very important changes in the industry in the recent times is we have got n number of sensors, but at the same time, the cost of the sensors have drastically come down now. Earlier, whenever I used to speak about PLCs in the early 1980s, it used to be always for a high-end automation. But now, with a very generalized microcontrollers or microprocessors like Adreno, Raspberry Pi, your CPUs are available for very cheap. So where you can tweak it and tune it to do multiple kind of projects over it. So next is decentralized network. So unlike earlier where internet was available only at certain places, now it's available worldwide. So internet is available and at a very affordable cost, and its infrastructure is improved. And we had earlier very a lot of disconnections and reachability and accessibility, but in today's generation we have accessibility to internet in a very good way. So but there is always room for improvement, but at the moment we are very good with this particular connectivity at the moment. And storages are available as very cheap, as known as cloud storages now. So again, cloud storage can be again segregated basically into two. One is for consumer markets and one dedicatedly for industry, because industrial cloud storage has to be much more secure and much more stable. So at the same time, we have got accustomed to use of lot of software and hardware usability. So everybody has got a smartphone, everybody has got a laptop, so everybody have got connectivity. So we are more and more accustomed to using this modern day tools. So somewhere 10 years or 15 years down the line, for banking sector itself, so we had always used to go to banks to withdraw money, deposit money, transfer money and all. And today we are doing it sitting at a home or anywhere just by clicking few buttons on my smartphone. So that has been the usability of this modern day tools. And again, data mining has become a very big thing. So it not only for the consumer industry, but even in industries, data has become a new fuel. So without data, I'll not be able to do much more advancement. So data has become very prime importance. So these all things gave a lot of opportunities for us to explore something on Industry 4.0. So what happened was, somewhere in 2008, the government of Germany, along with some big industrial giants, came together and they started discussing that most of the things are getting smarter. However, we need to make the manufacturing process or the manufacturing procedure of all these things also smarter. And then when this point was discussed, so by that time already IoT was quite popular. So they thought that why don't we bring this IoT into industries and try to enhance the processes. So when they came up with this concept, they started realizing that, so this is going to take the industry in a very, very big way. So if this is one of the biggest revolution in industry, what were the previous revolutions? So the first revolution was in the late 17th century, which was mechanization. So where we started using a lot of steam engines, steam turbines, steam power, hydraulics to automate our process in the industries. So almost after a century, the second revolution came, which was mass production, or generally referred as electrification. So we started using a lot of electrical components in order to simplify the automation process and take it in a big way. So one of the companies which first incorporated this particular industry 2.0 was a company called Ford. So basically they used to manufacture cars, and literally they used to manufacture around 1 to 2 cars every day with the mechanization process. But with the introduction of electrification, they could almost do that fivefold higher. So they could manufacture around 10 cars in a day. So which was well read by the other industries, and they started implementing this. So this was one of the biggest industrial revolution. And again, almost after a century, next came the introduction of microcontrollers, microprocessors. So this era began as digitization. So we started using microprocessors, microcontrollers, which led to PLCs, a bigger mechatronic system, and a complex robotic systems. And after this, as close as another 4 decades now, we are into a new era called as Industry 4.0. So this is the called as the fourth industrial revolution, where we are speaking about a lot of connected machines, connected components, and all those things. So these are known by different names across the globe, which can be called as Industry 4.0, smart automation, digitization, connected industry, or very appropriately known as Industrial Internet of Things. So this is what is the present trend, and this particular technology is a people-centric technology, which is developed in such a way that there is going to be a lot of huge job opportunities in the future. So we are lagging a bit behind because we are a developing country. So we have just started implementing these kind of things, whereas developed countries like Germany and Western states, they have done it in a very, very large scale already. So they called it as industrial revolution. Yes, it was a business revolution. We could sell products easily, you saying this particular concept, but when it comes to the product development and concept developments, this was an evolution, and we are come a very long way, and we have got sufficient enough. But again, this is one of the technology which is there to rule the industry for another 2 or 3 decades easily, because till today we are coming up with new concepts, and these concepts are being implemented in the industries. So very simple definition of this is people, machines, and IT systems automatically exchange information for the manufacturing products. So this exchange of information can be within a factory, or it can be across multiple ICTs. So, or within a company or within a group of companies. And we are one of the company who are dedicatedly working towards this particular technology. So in simpler terms, it is a merger of our core industrial technologies and IT-based solutions. So you can see n number of parameters here, which goes into making this industry 4.0. So in industry, here are few of the technologies which are transforming the way components are being manufactured and produced. So These are all general things which I think everybody can relate to. So one of the few of the very important things among these also is one is additive manufacturing, which we generally call it as 3D printing nowadays. We are working a lot towards augmented reality to give a better uh, maintenance point of view and better user experience for the consumers or users of automation. At the same time, we are also very much giving importance to big data and analytics. So where we are talking a lot about collection of data on and then studying from the data on how this machine will behave and how it will perform. So typically expectation from industries are all these things. So, but one of the important thing which all industries are looking for is from the maintenance point of view. So if you generally see in industries, every 6 months we have got an annual maintenance or periodic maintenance done. So this is again, people started finding a lot of a disadvantage with this, because even if my machine is in the perfect working condition, every 6 months I stop my machine for 2 days, replace few of the critical components and then resume back to work, by which I'm losing around 2 days of my machine time. So instead of doing that, what we have come up with is something called as predictive maintenance. So instead of periodically stopping the machine, with this big data, I understand the machine behavior and any deterioration in this particular parameters, I can predict that what could be the failure and accordingly take action and stop the machine for a minimal possible time and rectify it. So this is going to be the future called as predictive maintenance. A few of the advantages of implementing Industry 4.0. One is flexibility, because you get to use the programming language which you are strong in. Very innovative solutions, because these kind of machines and automation can be customized from customers to customer, machine to machine. So in the future, no two machines can be identical. So everything can be customized. Very unique, because we're using modern day simulation tools, what we call it as cyber physical systems. I can do all my preliminary setup, new product development, everything on a digital platform, and then straight away that can be implemented onto a real machine. Very, very efficient, because there are a lot of software tools, ready-made tools, by which my implementations can be faster and my efficiency can be increased. And this particular technology, Industry 4.0, unlike my previous three big revolutions, these are future proof, because it's software based and softwares can be upgraded. Just like what we receive a firmware upgrade on my mobile phones, same way product quality and enhancements can be done over a internet, even without the interference of any machines or anything. So when it comes to the education also, we are doing a lot of job, but there is a huge scope for the education also, because the engineers of the future will have to change themselves slightly for it. This I am not saying, but these are few newspaper articles which I have collected over a period of time. So in one of the articles, this was published somewhere in 2016 itself, it said that by 2021, IT sector is going to lose around 6.4 lakh jobs to automation. This doesn't mean that the requirement in IT industry is going to go down, but the actual statistics is there is going to be a huge surge and demand for the automation industry. Now, thanks to COVID, this has got slightly slowed down, and India being a developing country, it may not stick on to 2021, but at least by 2023 or 2024, this is going to be a reality in India also. So similar way, there was another article in the Huffington Post which said that Industry 4.0 could make India a global leader in manufacturing. The reason being, we have got the highest intellectual capital, So we have got best of the brains in India. We are one of the highest producers of engineers, and our population, 60% of our population are in the working age group. So which means the whole world is looking at India as the intellectual capital. So everybody want to harness that, and we could cash upon it only if we could adapt Industry 4.0 and learn about it and start using it. We get professional on it, and the world will look at India as one of the prime leaders for Industry 4.0. And this is just in the recent days. Big IT giants like TCS, Infosys, Tech Mahindra, Capgemini, these guys and all have started hiring in a very, very drastic way in 2019. So it is not that their IT projects are going in a larger scale, but all these IT giants have understood the importance of Industry 4.0, what will be the requirement of automation industry in the future, and they all have started a department or a separate business unit under them who are working towards Industry 4.0, which is going to be the future of automation technologies. So with this short introduction, I end my topic and I leave the session for open discussion. So this is one of the concepts which I want to show before I close. So we have been working with a lot of industries to train engineers. At the same time, we have been working with few prime education institutions. So where students are already learning about automation technologies, but in order to gear them up for Industry 4.0, we have come up with some unique concepts where using their existing infrastructure, we have brought it to the Industry 4.0 platform. And very happy to announce also, we have done a pilot project in an education institution in Mysore, where it's National Institution of Engineering, where we have converted all their automation related training system and we have brought it into the Industry 4.0 platform. So literally students now, they can sit at their home, they can access the training systems which are there in the education institution, they can develop dashboards, they are running some process, they are collecting data, and further using this data, they have started working on artificial intelligence, machine learning, augmented reality, all those things. And there are few companies who have already approached this particular institution for helping them to automate or digitize or connect their particular machines onto an internet platform. So very happy to say that students are working on such kind of live projects. So probably in the 5 years down the lane, we are looking at all the developments and all should not happen in the R&D facilities of the companies, but it should happen at the institution and university levels. So that is our prime focus which we are working upon. So that's all from my side. I'll leave the session open for any question and answers. So meanwhile, I have displayed my contact details also. So if you have any doubts pertaining to this particular new trend or these concepts, you can always get in touch with me also. So thank you one and all. So I leave the session for open question and answers. So if you have any questions, you can post it in the chat box, or you can directly unmute and you can ask me also. So I think I have covered it in the stipulated time now. So I leave the session for open for question and answers.
So Santhosh, it was an excellent presentation. We enjoyed our presentation. Thank you. You
Yes,
told that our India is intellectual capital of the world. About more than 60% of our population is working.
Yes.
This is okay, but the other side, any investment on the industry for automation, all these systems, it requires a huge investment, is it not? For that,
Yes, sir.
our India is.
Yes, sir. Now the thing is, again, thanks to COVID, because of most of the people had manufacturing setups in China. So now, because of this COVID, people are looking at alternate countries also, and in that list there are several countries. But among this a list of countries, everybody are looking at India as one of the prime hub for putting their manufacturing facilities. So that is the reason you can see this iPhone have started. Now Tesla wants to put their research and development wing in Bangalore. Now discussions are on. So there are a lot of multinational companies who are eyeing India as one of the manufacturing hub. But again, this will be possible unless and until we are geared up for it and the government supports for it.
Right, sir. Thank you, sir. Thank you, sir.
Thank you.
Now, session is open for questions. Members, participants
Yeah.
can ask questions, please.
So I guess there is one question here saying that electric drive replacing hydraulic and pneumatic system. My take on it. Yes, there are a few new technologies which are replacing hydraulic and pneumatic. So especially big earth moving equipments like BEML and all, they are trying to build a excavator system using electric technology completely. Yes, it's possible up to a certain extent, because when it comes to hydraulics, the main salient feature of hydraulics is its power density and the force it can achieve. So definitely electric drives can do that, but then the size ratio will be huge. So that is one of the thing which will, for bigger missions, then definitely there is no alternative. But yes, up to a certain extent, especially for the machine tool sectors and all, we have got something called as electro hydraulic servo actuators. So where you don't literally have a hydraulics, but we are using ball screw technologies and AC servo drives to replace hydraulic cylinders and all. Yes, up to a certain extent, electric drives will have an upper hand, but there are few applications and preferred salient features of hydraulics and pneumatics, which it is not irreplaceable easily. Hydraulic system nanotechnologies, there have been several work being carried upon nanotechnology and micro hydraulics, what we call. So we are coming up with new concepts for it. Yes, there will be a new development in this, but again, when it comes to especially industries, hydraulics and pneumatics will have its own importance and it will have existence. So no matter how much industry 4.0 progresses, but some of the key areas will have to be addressed only by hydraulics and pneumatics itself.
Sir, I have one more question. That is the automation, the industry 4, is it suitable for small and medium scale industries, sir?
At the moment,
Okay,
it is
for
a bit.
big automobile company,
Yes,
it's
sir.
okay. But how
Correct.
about small and medium company?
Correct, sir. So now the thing is, since this particular technology is in the very initial phases of development, it is being adopted by bigger companies like automotive, steel plants, and all. But generally, when we talk about MSMEs, so unless and until this product gets localized, see, now basically these products are available only from international companies like Bosch, Siemens, Hydac, and all those things. So unless and until it's getting indigenized and people are competent enough to use it, because now in the industry scenario, I'll tell you the exact scenario which I'm also facing. So I'm good with automation technology. So hydraulic system, pneumatic system, PLC programming, or electric drives, we are very capable of doing it. But at the same time, if you ask me to write a Java program or write a high-end algorithm for doing artificial intelligence, I can conceptualize it, but I cannot physically do it. At the same time, we have got very good IT engineers who are very good with programming skills, But when we talk about core automation technologies like hydraulics, pneumatics, or such kind of things, they are not even aware of it. So in the future, if we can adapt something that our engineers who are capably very good with their core technologies, at the same time they are good with programming skills, that is what industry is looking for at the moment.
Yes, sir. Thank you, sir. Thank you, sir.
How much advancement is required with computing with hydraulics and pneumatic systems, like monitoring several systems simultaneously? Yes, this is again, the concepts are coming up with a lot of IT based concepts. But again, as I told, IT guys can literally collect the data and use algorithms, and see, it may not be required for me to monitor all the data. So only certain parameters, when it exceeds some threshold value or something, then a trigger can be raised, which can be communicated to you, and then you can address to it. So these things are already there. But again, we need engineers who can do both the things. So now, though is a very good programmer, I ask him to develop algorithms, he may all do that. But if he doesn't understand the basic technologies, then whatever is implementing may not be suitable. So we need engineers or bright minds who can do multitasking and do the both the things now. In Coimbatore, what type of new plant plan to start? So we are basically system integrators or system developers. So we provide hydraulic systems for industries. But when it comes to our handling the logistics or our stores or the way in which the manufacturing process is saying, because see, at the end of the day, we don't manufacture the same component in bulk quantity. So our every product is unique. So these things has to be done at certain level, but the way in which we manufacture, track the process or track the raw materials, inventory management, these all things are on the IT platform now. So MATLAB in hydraulic pneumatic also is increasing because the programmable logic controllers of the new generation, whatever I've told. Now there are already libraries developed under MATLAB where I can use MATLAB to do the simulation part at the same time. Also, I can develop programs for my machine straight away using MATLAB. So MATLAB also is one of the prime tool where we are using it for a lot of simulation and development at the moment.
Thank you, Engineer Santhosh. I think there is no more. I think chat also I seen, sir. No more questions are there. I also read the chat, it seems.
Yes, sir. Yes.
Now, sir, we will move to next agenda. I request Dr. Kumaresan, our chairman, to announce next week program, sir, please, sir.
Yeah, next week I think lecture has been arranged in the mining area. So we yet to finalize the speaker, and once it's finalized, we'll circulate to our members.
Right. Thank you, sir. Thank you, sir.
Thank you.
Now
So,
I call upon for the vote of thanks. Sir,
yeah,
anything, sir?
Mr. Santhosh, it's excellent presentation, and
Right, sir, please.
yeah, any possibility of having the collaboration with our institute also, it's welcome. I'm from NIT Tiruchirappalli.
Definitely, sir. Definitely. We'll work towards it.
Yeah, thank you.
Thank you, Mr. Santhosh. Really, it was an excellent program. We enjoyed the program. Really, you took us to every, what are the positive areas for India can make it. Really, we'll work towards that, sir. We'll call upon you for any of our requirements. Thank you, sir.
Sure, sir. Thanks a lot, sir. Thank you, everyone.
Now, I call upon Mr. Suresh Kumar, the Treasurer of Indian Institute of Welding, Tiruchirappalli branch, to propose vote of thanks. Mr. Suresh Kumar? Suresh Kumar? 1 minute, I'll check up.
I think he is not available.
Yeah, he came in line, just.
Fine, sir. We can.
Hi, I'm sorry, Suresh. I'm calling you for vote of thanks. Audio, உங்களுக்கு Okay. Right, sir. Okay. Thank you. Sir, Kumaresan sir. Or is audio problem or network
No
problem?
problem, sir. Samidas sir is available with us.
Okay,
Sir,
okay,
Samidas
sir.
Good evening, Mr. Santhosh. It was an excellent presentation. I wish to thank you for accepting our request to make a talk on online. On behalf of all the professional bodies who have joined for this day's webinar, I extend our heartfelt thanks to Mr. Santhosh for his excellent presentation and giving us an idea what the future is having for us. And I wish to thank all the participants for joining in today's webinar. And once again, I thank all of you. Thank you very much.
Thank you very much, sir. Thank you.
Thank
Thank
you,
you, sir. Thank you, sir. Thank you.
Thank you very
Thank
much.
you, Mr. Santhosh. Really. Thank you.
Thank you,
really.
sir.
Thank you.
Thank you, everyone. Thank you.
Thank you, sir. Thank you.